Well, hello everyone. Welcome to the July quarterly webinar. Got some really great talks lined up. Got Tommy Johnson's going to talk a little bit about the research he's been doing with anonymous location data. We have Kale Bentley and Evan Booher from Washington Department of Fisheries and Wildlife going to talk about some of the recent improvements to the krill program there. And we have Katherine Papacostas from Fisheries. It's going to talk about the work that's conducted with the Marine Recreational Information Program, or MRIP. So with that, Tommy, do we have you on the line here?
Yes, sir.
All right, I'll stop sharing and I'll let you take it away.
Sounds good. Can you see my screen real quick, Dave?
Don't see it yet.
Let me see.
What's that? That one. I'd say the entire screen, that might be easier.
Okay, share.
Okay.
Let's switch. Any better now?
Yeah, we got you.
Okay. Hi, everyone. I'm going to be talking about anonymous location data today. And real quickly, to hop into what is anonymous location data, basically it's any smart device that has a GPS chip in it. So think Apple Watch, smartphone, tablet. It's using the GPS chip in there to act as a logging service with this software. And basically what we're trying to do with this software is just understand where people come from, how long that they're spending there, and roughly some of the it's more just visitation logging, to make it simple. This is different than what geofencing is, which is usually where you draw a perimeter around an area and then you're pushing some type of notification, such as a survey or a review to people. And the nice thing with this software is we are not collecting any personally identifiable information. And so that way we don't have to go through the IRB process. So real quickly, some of the stuff that we can collect is trip origin. We can see what states people are coming from. We can get trip duration and timing, see what the busiest days of the week, when the fishery is taking place, or when people are recreating the most. We can collect some demographics, and that's based off the U.S. Census block data. And then, so kind of how we're using this tool, just to give you a little bit of background on it, is we're using this to kind of help replace a mailed survey that we conducted for about 20 years. And basically, instead of sending a mailed survey and realizing we weren't getting the numbers that we wanted to, and also not answering some of the questions needed for the program that I'm working for right now, we decided, could we find some type of software or some type of program out there that can help us identify a better way to get the answers that are needed to help their program. So what we did was we ended up breaking down the past survey into two categories: visitation and travel information, and opinion and activity information. And using anonymous location data, we're going to get the visitation and travel information going forward. So through using anonymous location software, we came up with several different scenario questions that we wanted to test and see if we could use the software and understand what the limits were and the extent to which we could use this, because if it wasn't going to work for us on most of the stuff we needed it for, we really didn't feel comfortable going forward with it. However, if it did work for us in a lot of different situations, this was maybe a tool that we wanted to go forward with. So the ones we're going to be looking at today are a small scale change, a difference between trout stockings, high use areas, and with campground data. So moving on to our first one, small scale change. We're looking at Red Haw State Park. The reason that we chose Red Haw State Park is because we had a known time period where the park was closed down due to a tornado coming through it. We figured by using the software, we could go in and look and understand what was happening at the park in the days leading up to the tornado, and then see that it was closed afterwards. So when we got the data back for anonymous location data, you can see on March 6th, that's when the tornado came through. And the days leading up to it, we had people out there. And then for a few days afterwards, we had people coming to the park to help look at it, do evaluations, see what was going on. However, from March 12th till about March 26th, we didn't have anybody out there. And that was something that we were interested to see because we weren't picking anybody up. However, on March 27th, you may be wondering why we had such a large spike since the park was closed. Well, the park ranger at the time ended up having a park cleanup, and she decided to have people from all age groups come out and help and volunteer just to try to get the park back in shape to hopefully reopen it. And from that, we were able to see that there's about 380 people that came out and helped that day with the park cleanup. And through talking with the park manager, we found out she had about 420 people that came out to help on that day. And through this was our first case study, and we felt pretty comfortable with it going forward because we did see pretty good numbers, and this is a single lake, small scale use, and we were able to see what was happening at the park. So, can it detect change on a small scale? Yes, I would say I'm pretty comfortable with it based off this case study. Moving on to our next one, we wanted to look at trout stockings and see if we could detect a difference there. The study site we chose is Terra Park. The reason we chose it is because our urban biologist routinely stocks this lake, and we could get some pretty good information and know roughly the time frame that when it was stocked, and then collect data on how long that fishery was staying in there. So this is the announced trout stocking. The blue dotted line is going to be the stocking date, and as you can see with an announced trout stocking, that fishery gets hit very hard, very quickly, except for that second day that it's out there. It might have been weather related. It might have been something else. We don't know what the low cause of that number is, but it's hit pretty hard, and then you don't really get anybody coming to the fishery, and then except for the weekends. And then when we overlay that with unannounced trout stocking, you can see the first couple days that there really aren't anybody out there fishing for those trout because they don't know they're there. As soon as the public finds out about the trout stocking, you see the usage ramps up, but it stays pretty consistent throughout the month. So when it comes to making management recommendations for stocking, if we want that put and take fishery to last 1 week and say doing a kid fish event, and then knowing we need to stock it again if we want people to continue, then maybe the announced trout stocking is the best way to go. Now, if you want that put and take fishery to last a while, what you would want to do is do an unannounced stocking and let it have about a month to go, and then potentially reevaluate it for stocking after that. So detecting differences in usage for the stockings, yes, we did feel like we could see a difference, and we were comfortable with it. So moving into high use and low use areas, the goal behind this was to use one of our most popular lakes and then a small area as well, because we wanted to see, did we get accurate results in those areas? So our high use lake is Saylorville Reservoir. It's one of the highest ranked usage lakes in the state every single year. And we have a lot of people coming to it. It's about 15-20 minutes north of Des Moines, which is the state capital. And so you get a lot of usage around it. Well, when we started going in and looking at the software, it was saying we were getting about 16,000 people a day. Having been on that lake a couple of times, we're not getting 16,000 people a day. And we realized that that just wasn't the case. And we wanted to figure out what may be causing that, because it wasn't reflective of what was actually happening. That being said, what we learned through using the software is the purple color on here is roads that can potentially cause issues with inflations of numbers by picking up people that are going through the area. The red rectangle is an area that we may have potentially picked up a house or two that we're picking up, and maybe a little bit of a subdivision at the bottom right side. And then the yellow circle is actually an Iowa National Guard armory. And what we figured out there is we have about 10,000 servicemen and women that are coming in each month on the weekends, and they're potentially inflating those numbers because they do fall on public land around the lake. So these are all areas that you may need to exclude when you're drawing a polygon to use with the software, because it will inflate your results. Moving to a low use area, this is the Little Turkey trout stream. And when we looked at it, we had some krill data to compare it to. And after we ran the software and looked at it, we ended up getting no results for this area during the time frame that we had krill results. With this being said, some of the issues may have been that there wasn't cell phone service. It could have been that nobody had a phone that was capable of recording or collecting the data on it and then sending it. And then the other thing may be is that people just didn't walk into the polygon, but knowing that we had the krill survey and we had several krill clerks out there that collected data, we know that wasn't the case. So does it work well in a high use, low use area? As of right now, I would normally say no, but looking back on it, it does work, but you need to kind of reflect and think back on what your main question is you're going to ask, and then also what the situation may arise. So you can use it, but you got to be strategic in how you plan to use it in certain areas. And then, can we ground truth this with other types of data? So we're looking at Slip Bluff County Park. The reason that we wanted to look at this lake in particular is because of the past MELD survey that said during our 3-month busiest time period that we were only getting 3 people out there to recreate, and we just didn't feel that was the case. So when we ran it through the ALD software, we found out there was really about 4,000 people going to it. And then we contacted the campground and we found out that there was about 2,000 people staying there during that time frame that they had a record for because they had checked in during that time frame. Well, one thing we were wanting to know is why was it about 2,000 off in terms of our number? So one thing that we discovered is if you see the yellow circle up there at the top left corner, that is a bus station on International Highway 35 that allows buses to pull in. People can get off, go inside the travel center, and then they can also walk down to where the little purple rectangle is, and they can stretch their legs and go into it. And since that picnic area falls within our polygon, we're actually seeing that lots of people are coming in and spending a little bit of time as they're traveling up and down through the bus systems. And we can see that based off of the trip duration, which we get. We can see that for our 15 minutes to 2 hours, 37% of the people that are coming are in that time frame. So just quick enough, 15, 30 minutes off the bus, and then they're back and traveling again. As where our campers that are at the campground, they're staying for 5 hours plus, which makes that 45%. So after looking at those numbers and understanding what was happening based off of seeing where people were coming from and how long that they were spending time there, we felt pretty comfortable with this. Moving forward, we're still trying to look at it a little bit more and understand different areas that we may be missing some in terms of numbers, but we feel comfortable with it. So real quickly, just to kind of leave y'all with what we felt like was a good answer for the program and the case studies we were looking at. Small scale change we're comfortable with. Difference in the trout stockings we're comfortable with. High use areas we're still trying to get a good grasp on here. And then with our campground data, we're comfortable using that as a way to check the ALD software. Real quickly, we want to run you through some of the known issues. So if you are interested in the software, you know what could occur or what may happen. This is a new and emerging software. The companies are still trying to figure it out. Some of the graphs that you saw in this presentation is from a company that decided to step away because they were going a different route with their business. So I've been looking at different software providers and looking at the types of data that they're going to use, first person versus third person data sites, and then also seeing which companies have a longevity business plan that will work for us, but also seeing what they're going to do long term for themselves as well, since this is a new and emerging field. Something that does cause issues is roads. You do have to be careful when you're looking at areas. If there's going to be cut through roads, major highways, or anything else, it's something that is going to play havoc with your numbers from time to time. The companies are still trying to figure out why, but we found out through using the software for one of ours on Sailorville that this is one of the reasons that we do have issues. Another thing to consider is when you have a large scale event, such as a concert, such as an Ironman race, biking, anything else, even the Iowa National Guard Armory that we have there on Sailorville, that when you get a bunch of people all coming into an area quickly, it may inflate your numbers and throw it off. If you are going to be using the software, you need to take that into consideration and talk with the biologists in the area for events that you may see that are outliers moving forward. And then the last thing really to consider is at the end of the day, if you're going to an area where you just have one or two people, this software may not be the best use for it because you may not pick them up because they need to see a number of people and devices that are registering in the account before they can say they got enough to put a number out there. If you're not getting that, such as like with our little turkey trout stream, it may not be a beneficial tool for you in your program. With that being said, I'll take any questions if we have time.
Yep, we got time for a few questions. So
Okay.
Just start.
all right, I think Mitch has one. Go ahead, Mitch.
Hey, appreciate the talk you gave. The one that jumps out to me was the trout stocking stuff. Could you go into a little bit of what kind of costs you associate with gathering that kind of information with the unannounced versus announced stockings? And I'm guessing it's like a per polygon type situation.
So it depends on the company is what it breaks down to. Some companies charge a subscription fee. So the subscription fee can be $19,000 up to $40,000, and they'll let you draw as many polygons as you want for the entire year that you have that subscription and collect the data that you want. However, there are other companies that I've looked at that will say you're paying for the data line itself, so you can have as many polygons as you want, but you're buying the amount of data. So, for example, we looked at one company and they said for the 140 public lakes here in Iowa, if we wanted to get a year's worth of data, that'd be $32,500 for their company, and when you broke it down per lake, it'd come out to about $252.50 per lake for a whole year.
All right, we got time for one more question if anybody else has one. We got one typed in here. Do people need to opt in to something to be counted by the software?
No, they don't have to be opt-in, and it comes down to first person or third person apps. First person is like your weather apps where people automatically have it downloaded on your phone, and the companies own those apps themselves, and they're collecting the data from it. Now, if you have like the McDonald's or Starbucks apps, and they ask, do you want to allow your GPS to be on so you can find the nearest restaurant? Technically, you opt in right there, but you don't have to opt in every single time. It's usually that one time they know where you're at, and then they get the data from those third-party apps to collect the information.
Talk about how the one we prefer works.
The one that we're looking at right now is a first-party data source. So what they do is they own a weather app, and they own several other apps that they own the apps themselves. So they're collecting all the data from the apps, and then they throw it in their algorithm. So they know it's going to last long term, as where third-party apps are moving to the point where there's lots of states enacting laws that are privacy laws that third-party apps are no longer really going to be able to sell as much. So we are going forward with the first-party apps because they do own the apps, and they're not selling the information. They're just using it internally to help their algorithm and their software.
All right, we'll go with this last question, and then we'll move on. Question is, how does the software determine your home location and demographics?
Okay, so what it does is it takes in your dwell times that you have, and usually you have 3 dwell times throughout the day. One's a work dwell time, one's a home dwell time. Then the other one is kind of like you're out and about doing stuff dwell time. And so they look at it on the terms of wherever you spend 8 to 10 hours every single day, it will count as your dwell time. So they think that's your time that you're home and staying there, and they require you to be there 30 days before they count it as your home time. Once you stay there for 30 days, it'll keep that as your dwell time unless you move somewhere else, and it takes another 30 days for it to reset.
And it's a census tract number.
And it's based off of where the census tract is for your phone during that time frame.
All right, Tommy, thanks a lot. I see we got another question here, but let's try to, we're going to try to stay on schedule and move on to the next talk here. But Tommy, maybe you can put your email address in the chat here, and if you're comfortable with that, maybe we can answer some of those questions over email. Anyways, we'll move on to the next talk with Evan and Kale.
Good morning, everyone. And a second, let me get this.
I think we're seeing, yeah, there it goes.
Okay, is that good?
Yeah.
Okay, awesome. Yeah, well, first off, thank you, Dave, for the invitation to invite today. And thank you, everyone, for taking time to attend today's quarterly meeting. My name is Evan Booher. I work in a coordinating role for monitoring of freshwater salmon and steelhead fisheries for WDFW. And my co-presenter, Kale Bentley, is a research scientist who works in the science division. And he works on various projects of life cycle monitoring and other population monitoring projects out of the lower Columbia River area of the state. Today, we'll be giving you kind of an overview of some work we've done to improve our monitoring of freshwater salmon and steelhead fisheries. And we'll be highlighting some past challenges, recent solutions, and looking at some future directions. And so why we wanted to be here today and what's our motivation for presenting. We want to provide some context for WDFW's freshwater creel work. We're then going to work through some key areas of development for the program, which is currently focused on river basins of Western Washington. And ultimately, what we're looking for is to kind of better engage with this community and invite further collaboration so that we can be learning from each other and ultimately better informing management of our fisheries. So why freshwater creel? Many reasons across this pretty diverse group. Here in Washington, we really need robust harvest estimates to be managing our fisheries to meet management agreements and guidelines. And so we want to be using an understanding of the basic population biology of our exploited stocks. And so as part of that, we need to know the abundance, demography, and harvest to understand what kind of impact we're allowed to have from our recreational fisheries. And our obligation to be monitoring comes through a couple of different pathways. This includes co-management with treaty tribes. We also have federal statutory obligations through the Endangered Species Act, as well as international management obligations through things like the Pacific Salmon Treaty with Canada. In all of these, we are working to make sure that we are meeting our conservation objectives and staying within guidelines of these various agreements. So going through kind of a pretty fast overview of some long history, we have kind of a rich history of both offsite and onsite creels for freshwater salmon and steelhead fisheries in the state. This begins with offsite punch card methods in the 1940s, and moving into the 1970s, more of an emphasis on on-site methods, and that was following the need to validate harvest with the landmark Bolt decision court case of 1974, which determined allocation of harvestable salmon and steelhead between the state of Washington and treaty tribes. Moving forward in time into the early 90s, the agency adopted our standard creel manual, and that came out around the same time as the well-known, at least to this group, Pollock 94 Angler Survey Methods publication. Underlying this kind of timeline is a shift from harvest-focused fisheries from kind of the beginning of the timeline. And those kind of persist through time, but arising in the 80s, we have the rise of the need for market selective fisheries. And these came in response to decline and eventual ESA listing of multiple salmon and steelhead stocks in the Pacific Northwest. And that was kind of one impetus for the need for more on-site methods to be monitoring these fisheries. So at present, we have two main approaches for estimating catch from these fisheries. We have our main off-site method, which is called the catch record card or CRC system. And then we have on-site creel. And if we do kind of a quick comparison of these two methods, we can see how there's kind of three main considerations for which method we are choosing. And these include the type of fishery, whether it's harvest focused or also includes a catch and release element. There's then the timeliness of reporting. So do we need the information to be making decisions in season, or is it just a post-season evaluation? And then there's the cost and feasibility of the approach. And what you see from this comparison is that CRC is a very cost-effective way to be monitoring large areas and a large number of fisheries, but it falls short in terms of its ability to provide data on catch and release and also incidental impacts, and then also the timeliness of reporting for in-season data. And so that puts us on the use of on-site creel to be getting this kind of gold standard for monitoring, but it comes at a cost of kind of a larger pile of gold or money. And so in recent years, there's been a need for on-site creels in our fisheries, and the overall expansion of this work highlights kind of the key challenge for us, which is limited coordination among regions and across species that we are monitoring. And so by isolating projects across different districts, where we've been a bit slow in sharing what does and doesn't work, it becomes harder to compare patterns at larger basin scales, and there's greater risk of bias with inconsistent study designs. And so some of the solutions that Kale will walk through include better coordination to improve study designs, data management, and we'll focus on showing kind of a new innovative model as part of that. And then one last thing we're doing is we're increasing the amount of dedicated creel staff with focused expertise on these topics. And so showing that same timeline is just going to show you kind of in recent years, some of these different boxes, which are going to map to some of these different areas that Kale is going to walk through for where we are working to improve our overall program. And so from here, I'll let Kale take over.
All right, thanks, Evan. Good morning, everyone. This is Kale Bentley. And yeah, so I'm just going to walk through basically 4 categories of challenges and some solutions that we've come up with over the last few years. And so jumping into the first one, as Evan previewed, and I'm sure everyone here knows, these angler survey methods have existed for a very long time, more than a half a century of methods that have existed that we're largely still relying on today. And really good resources have existed for decades. And so Evan highlighted one that most of us here are aware of, which is this Pollock et al.'s Angler Survey Methods book that was published by AFS over 30 years ago. And so if you can find a copy of it or get a PDF version of it from someone here in this group, you can see that this book provides guidance on a wide variety of creel survey approaches and data analysis that can be used for a bunch of different types of fisheries that can be easily implemented by people with limited statistical experience or programming. And so that's great. But however, not only are these estimators in this book or similar resources, caveats, which I'll in a following slide, the data collection methods are quite generalized, meaning that the actual implementation of the creel using this guidance can be quite variable. And so while broadly speaking, I'd say this is a positive. Within an agency, as we've learned, this isn't necessarily a good thing because you can end up with many different survey designs and data collection fields for effectively the same type of fishery in different areas. And so not only is this inefficient, comparison among fisheries quite difficult. And so our agency's first priority when it came to improving our creel programs was on standardizing our data collection protocols. And so because we were largely implementing what is known as roving surveys for salmon and steelhead freshwater fisheries, we developed a detailed study design and protocol that included everything from these high-level components that needed to be there and a description of those down to the minutia of, these are the specific interview questions we want to ask across all fisheries. These are some optional ones, and these are what the data types need to look like, with the overall goal, again, of generating unbiased estimates. Ask some supplemental stuff for other questions, but we're going to be estimates of catch, and so this is the components we need to have. And so I'll say that, despite the fact that, these protocol documents are never going to win sort of any sort of literary prize and sort of, allow any of us to sort of get famous off them, I'd say they're the ones that I'm personally sort of most proud of, because they're easily the most important aspect of our creel-related updates, as this standardized approach form the foundation of this kind of enterprise scale workflow that we want to build. And so with that sort of in place, we were simultaneously working on sort of this next sort of challenge and solution, which is, go ahead, there we go, which is working on our data collection and storage. And so here, the main challenge was that we had no centralized database for creel data, and data collection occurred exclusively, with pencil and paper. And so by not having a centralized database, project leads were exclusively handling data into spreadsheets that were stored on personal computers. And I don't really need to elaborate on sort of the issues that, sort of persisted with that approach. And so we worked with an internal team to build a relational creel database. And so, although I didn't mention this in the previous slide, our strategy here was was similar to standardizing our protocols, is that we started small. We started within like a single region on a select number of fisheries. And so rather than trying to sort of build and deploy this perfect system and sort of implement it top down, we built a database with a framework that we knew would generally work by talking with lots of projects around the state, and that by demonstrating its utility and showing that we can be successful by using this, the user base has quickly grown, and it is now truly our sort of statewide creel database. And so over the past few years, there's been a few different iterations of what this database has looked like, but today it's built in PostgreSQL, hosted on Amazon Web Service Cloud, and the data is synced to a public-facing web page multiple times a day. And we've also simultaneously developed electronic data capture using iForm software, where creel data can be synced into the database in real time. And so with the study design, standardization, and data collection storage in place, it allowed us to sort of move to our data analysis. There we go. All right. And so quickly rewinding again a few years ago, the core challenge here was similar to what we faced with study designs, is that across creel projects, when data are being stored locally, people have to analyze it locally, which means we get sort of inconsistencies in how people were analyzing their data, which is not only redundant. In some cases, we were finding that it wasn't done correctly, and so we were getting inaccurate estimates. And so in the last few years, we've developed a standardized, user-friendly creel analysis in R, where estimates of catch and many other metrics are generated in a 4-step process, which involves importing data, wrangling it, generating estimates using a couple different models, and then summarizing it with a suite of standardized outputs. And so while I imagine, script-based analyses are becoming the standard now everywhere, one small, but I think exciting aspect that is at least new to our agency, is that we have this entire analysis hosted on a public-facing GitHub repository. And therefore, anyone can, view, borrow, critique, and in theory, help improve what we put together. And so, again, while I think this is a pretty big deal, I guess in full transparency to this group, what we built was largely something for us to use, which will likely be the case, at least in the near term. And that's because, the core of this analysis is structured around our creel data and data structure. But in time, what we want to do is partition the analysis and expand on the study designs or the different types of creels that it could be used for, and then start converting it into some packages that are just more consumable by a wide range of people. And so, all said, for anyone here who's implementing roving creel, we'd love to have some follow-up chats to talk through our methods and analysis framework. All right, so then moving to our last one, which is staying on the topic of analysis. And that is, we've started, well, we have, and we're still kind of iterating on it, of developing a modernized creel model. So why did we do that? Well, as I previewed a few slides back, the established sort of method of moment analytical approaches for creel data, such as those described in the AFS Angler Survey Method book, they were developed, many decades ago, which simply means they haven't leveraged recent statistical and computational advancements. And these approaches have several limitations. And so just quickly highlighting a couple of those. First, they ignore sort of the generative processes of the data, which can result in unrealistic estimates. They ignore temporal and spatial autocorrelation, which we expect to see in creel data and actually can use to our advantage with an appropriate model. Third, they largely ignore the need for spatial expansions, which can lead to severely biased estimates for these geographically large fisheries, such as the ones that we're implementing in a lot of places. And then they also ignore several components of uncertainty, which means that the total estimate of uncertainty will likely be underestimated. And admittedly, I'd say this one is maybe not super important based on how we and maybe others sort of consume this data. We largely don't focus on the uncertainty, but we're slowly inching towards probabilistic based management. And so this will actually be really important once we move to that. And so all said, given the limitations of these existing analytical models, we developed a Bayesian state space model in STAN to analyze roving creel data with the goal of having a tool that can generate estimates that we feel are truly accurate for both central tendencies as well as estimates of uncertainty. And so for today, I didn't want to go into the details of this model, but that said, it is on the same GitHub repository I previously highlighted, and we're trying to get this published in a peer-reviewed journal, hopefully later in the year. And again, if anybody is interested in this, we're more than happy to follow up one-on-one or in this group. And so that's just a quick overview of some of the things we've been working on over the last few years. And then I'm going to throw it back over to Evan, who's going to give an actual worked example from a specific freshwater fishery that was focused on fall coho in a river in northern Washington called the Skagit River.
Awesome. Thank you, Kale. And I'll try to speed this up, knowing that we are running up, kind of blasting through our time. So a pretty simple worked example that we wanted to show for the group here was, again, the Skagit fall coho fishery. And this is a fishery that's co-managed between the state and 3 treaty tribes. That fishery is planned through a season setting process called North of Falcon, and that is setting up the kind of the catch allocation among the different fishing groups. And some key things with this fishery are in-season monitoring to evaluate where we are at with our total harvest, as well as impacts to ESA listed Chinook, and that's specifically a Skagit summer fall run. And so we creeled this fishery, and I'm showing some results from the 2022 fishing season, so last year. And so we monitored this using our standardized roving design from September through November. And with the data aggregated into 6 river sections, they are ordered here from most downstream in panel 1 through upstream at panel 6. And this represents about 75 river miles that is open to salmon fishing in this season. And the panels each show the output from the Bayesian state space creel model, with estimated median daily harvest of coho salmon grouped by angler type. And so that's either fishing from the bank or fishing from a boat, and the associated 95% credible intervals on the y-axis and date on the x-axis. And One of the key things here is showing kind of the power of the in-season monitoring. And so in this black box on areas 4 through 6, what I'm showing here is a time in the season at which we knew we were getting close to going over our allotted Chinook impacts. And so this was an opportunity to be leveraging the data in season to make management decisions, to use what we know about the spatial patterns of catch of Chinook to make some temporary closures to the season. And so that the data on Chinook catch was used to justify these closures, which are represented by those areas of no catch or zero catch in 4, 5, 6 with the black arrows. And by acting in a timely manner, we're able to prevent an overage on Chinook impacts and thus preserve additional fishing opportunity for this coho fishery. And showing just kind of a final results, the best estimate of coho harvest was around 6,700 fish, with CIs ranging from 5,700 to 7,800. And so kind of the two takeaways here are, again, the in-season monitoring, getting managers the data they need to make sure that we're staying within conservation guidelines, and then showing how this can be used to maximize fishing opportunity. And that was really kind of the idea, kind of showing kind of the full time series of coho harvest, knowing that if we had, kind of broken that conservation guideline on Chinook, this harvest that we got to provide to our constituents, wouldn't be possible. So, yeah, that's kind of the end of the worked example. And as Kale mentioned, we do want to be working towards a more probabilistic design for how we're leveraging uncertainty in our monitoring and management framework. And those are some tools that are still in development. So I will put it back to Kale to wrap things up.
Yeah, thanks, Evan. So in the last 30 seconds or so, we just wanted to, again, thank you for the time today for letting us sort of showcase what we've been working on. But also highlight, like anything, the work usually is never fully complete. Other things sort of still need to be addressed. And so here, sort of at a high level, the two things that we're really focused on is continuing to deploy, what we've developed to a wider range of fisheries in our state, which includes marine waters and inland fisheries, as well as co-managed fisheries. And so there's going to be some challenges there working with a wide variety of people, but one that we think is really important. And then secondly is trying to figure out a way to continue to generate these estimates of catch, and specifically for in-season catch as well as non-retained catch, without having to deploy as many of these extremely expensive creels. And so what we'd like to do is develop, to basically expand on our catch record card system and do what our agency to the south, Oregon Department of Fish and Wildlife, has successfully done, which is implementing an electronic catch record card system, which I think should happen sooner than later, as well as leveraging some of the really innovative sort of work that they've done. And I've highlighted it here on the slide by Brian Riggers and Michelle Jones, where they have like a really clever way of estimating catch using a mark recapture technique that basically removes the need to do these effort counts, which are really costly on a lot of our fisheries, as well as expanded, again, like I said, to non-retained fish, which poses some challenges, but one that we think is really important. And so, work is underway, and we're excited to, have this group to collaborate with moving forward. So thank you for the time.
Yeah, great talk, y'all. Really appreciate your presentation, and y'all are doing some really awesome stuff in the creel world. Unfortunately, we bled a little bit into the next talk. So if y'all have any questions, go ahead and put them in the chat, or you can reach out to Kale and Evan. And with that, we'll move on to Katherine. If you can share your screen and take over the talk.
Sure. Sure. So can you see my screen? It says it's sharing.
Yeah, I can see it.
Okay, great. Okay. All right. Well, yeah, thanks everyone and David for the opportunity to talk to you all today. I'll try to get through this quickly. But my name is Katherine Papacostas. I am with the NOAA Fisheries Office of Science and Technology, and I'm the Program Management Branch Chief for the Marine Recreational Information Program. So hold on, let's see if I can get the slide to change. Okay, so MRIP is a collaborative partnership that works to implement and improve a national network of recreational fishing surveys. These surveys collect catch and effort information that's used to help inform stock assessments and also monitor landings for fishery management. So recreational data collection at NOAA Fisheries has been ongoing since the 1980s, but especially in the past 15 years or so, we've undergone some iterations and improvements and expansions based on objective peer reviews and partner feedback. The most recent large peer review of the program was conducted by the National Academies in 2017, where they affirmed the improvements to date and also made more recommendations that we've been looking into to continue to evaluate potential sources of bias and test additional improvements. So I have on this slide a cycle here of evaluating current methods and testing new methods and implementing them. So a fairly standard, scientific process. But I'll say implementing new methods isn't as easy as it may sound, as in the system that we all work in, as fisheries professionals, which relies on consistent time series. So I'll cover a little bit later in the presentation the process that the agency has established to try to maintain that consistent trend information that's so critical for assessment and management uses. So the program, as I've mentioned, is a state, federal, regional partnership. And so there are different roles at different levels. At the national level, NOAA Fisheries provides survey research expertise, both in-house and then with statistical consultants that we work with. We provide technical and funding support for, developing and improving and implementing surveys at all levels of the partnership. So the federal, regional, or state saltwater fishery surveys. We produce and house sample frames and federal data products. We set national standards for surveys and data quality. And then we also facilitate independent peer reviews to try to ensure that surveys at all levels of the partnership meet minimum quality standards to try to kind of feed into the federal system. At the regional and state level, we work with the regions and states to collaboratively administer surveys and maintain sample frames. We do collaborative quality assurance, quality control of data at all levels of the data collection aspect of the partnership. And then conducted at the regional level is what we call regional implementation planning. And that's setting recreational data collection priorities and regional needs. And then also at the regional level, there's work to maintain those consistent time series when shifting survey designs, which I'd mentioned already. As far as who the partners are, the fisheries information networks and interstate marine fisheries commissions are really close partners in data collection and data management, and lead those regional implementation planning processes in a lot of regions. We also have the fishery management councils who provide really important input into those regional plans. And then, of course, the state agencies are the ones that are out in the field collecting a lot of the data. And then they also provide input into those regional priority setting processes and into transition planning with shifting to new designs. So as far as at the national level, I'll just kind of walking through our key functions. As far as our data products, we have raw data and estimate data sets. We have a query tool that lets you explore our estimate database. We also have custom domain estimation programs for users if they need to produce their own estimates to meet distinct needs. And then we have a lot of documentation and user guidance. So all the purple in this presentation are links. So if these slides are shared afterwards, which I hope that they will, please feel free to look through them. And if you're interested in any particular thing. As far as the sample frames that we house at NOAA Fisheries, we do have a public fishing access site register that has all known sites along the Atlantic and Gulf coasts. Then these next two here are protected data sets, so not public, but we use them to sample. And we have a national angler registry that pulls from most of the state saltwater license databases. And then we have a for-hire vessel registry that has information about all the known charter boats or head boats that we use to sample. So continuing to walk through our key functions, we formally adopted National Survey and Data Standards back in 2020. And we've been slowly phasing them in. They were established essentially to promote data collection and distribution consistency across the saltwater fishery surveys nationwide. And so these are our 7 standards. Most of them relate to developing comprehensive documentation. So standards 1 through 3 put a lot of emphasis on survey and methods documentation, detailed enough for peer reviewer evaluations, and also detailed enough so that someone of comparable, background could pick up your methods and your quality control procedures and replicate what you're doing. So that level of transparency and clarity. Standards 4 and 5 relate to 2 agency policy and procedural directives that I've linked here. I can talk about more later. Standard 6 relates to ongoing evaluation of survey designs, tracking implementation challenges, and also documenting unmet needs and plans to address those. And then finally, Standard 7 is all about standardization of information products and information management. So things like data accessibility of estimates and raw data, formatting standards for improving ease of access for data users, protecting confidential data, and standards for precision. So all kinds of information management and standardizing those products. So standard 5 on the previous slide was the review procedures. And part of that, I mentioned that there's a policy directive relevant to that. So it's called the certification process. And this is essentially a process we've established as an agency to try to best support implementation of scientifically sound methods across the country. So with this process, we essentially facilitate an independent statistical peer review. And when a survey is certified, it doesn't necessarily guarantee funding, but it does make that survey eligible for funding because the agency generally wants to support methods that have been thoroughly evaluated through peer review and are scientifically sound and meet minimum quality standards. Certification also doesn't guarantee implementation or use in federal fisheries management. Decisions on how to use data from a new survey are actually made independently from the certification process. So certification is really focused primarily on the soundness of the statistical survey design. And I think actually at the last quarterly meeting, Chris Wheaton showed you this slide when he talked about RecFin, so I won't spend too much time here, but this is just, the purpose of this slide is to show the extent of saltwater recreational fisheries data collection efforts nationwide. The majority of these programs are ones involved in the MRIP partnership or that NOAA Fisheries interacts with in some way, whether it's through funding or technical support or involvement in a regional implementation team. And regional implementation teams essentially bring all the key groups to the table that are involved in the recreational fisheries management system. So the states, the interstate marine fisheries commissions, the fishery management councils, the NOAA Fisheries regional offices and science centers. So among these teams' functions are developing regional implementation plans. And these are 5-year plans that identify regional data collection needs and priorities, and also funding and technical support needs. So again, developed at the regional level and then back up at the national level, we take those plans and really use them to inform decision making, looking for cross-regional priorities and prioritizing funding for some of those needs. These teams the regional implementation teams are led by the fisheries information networks in regions that have those. In regions that don't, they're often led by a NOAA Fisheries Regional Office or Science Center, or in the case of Alaska, where that state is really hugely involved in a lot of the fishery science and management, the state's the lead there. So, and then kind of our final key function that I listed at the beginning is transition planning for implementing new surveys. So new surveys, as we all know, have a variety of benefits. They can be an improvement to a prior method, informed by new knowledge or new statistical techniques, or a new survey that can meet a need that a prior survey didn't meet. So with evolving management needs, you may need to come up with new designs for those particular needs. But whenever a new survey is developed or an existing survey is improved and has been appropriately reviewed, and we identify it's the right way to go, the partnership then follows what we call a transition process. And the goal of this is to preserve continuity of historical catch and effort information and minimize disruption to the extent possible to fishery management processes. So a big element driving this transition process is no method, no matter how scientifically robust it is, it's not going to be 100% free of error. So, and using different methods introduces sources of variation unique to those methods, and that can impact the scaling of estimates. So it makes it challenging to compare estimates across different surveys. So just generally, the process consists of 5 steps. The first 3 are responsibility of survey administrators. The last 2 are the responsibility of assessors and managers. So we start with benchmarking to the extent possible, conducting the old and new survey side by side to compare them, then developing a method to calibrate. In other words, be able to compare or relate old and new estimates to one another, and then apply that calibration method to our historical time series to try to rescale the time series to the new method that's going to be used. And then those methods can be incorporated into the assessment and management process, and those new estimates can be incorporated. So I've linked here, if you're interested to read about them later, 2 example transition plans we've developed. One was for a large-scale federal survey. The other is an approach to incorporate a suite of state recreational fishing surveys in the Gulf of Mexico into the federal assessment and management process. So this process can take time. The second step of developing a calibration can be challenging when especially if you have multiple new designs you're working with, or if there's big differences between the old estimates and the new estimates. It's also, as we all know, management's happening now, not 5 years down the line while you're trying to do all this prep work. So it takes a lot of communication and coordination across the whole system. So I know we're running low on time, so just quick key takeaways. The program is really focused on statistical quality, and the methods that are developed focused on standards to promote, national consistency and transparency as much as possible. I can't emphasize enough the critical role that the state and regional partners play in the program's key functions. Another final point is, not all data is created equally or designed for a specific purpose. So we do work with fishery managers to help them understand the strengths and the limitations of our data to best inform their decision making, and continuously, work and research and evaluate ways to improve the quality of the information that we put into the system. So that's all I have. And I think we got a few minutes left. So thanks for your time and the opportunity, and I'd be happy to take any questions you have.
Yeah, great presentation. Thanks for coming today and giving that talk. I actually have a question. This is, for creel surveys across the U.S., this is kind of a black box with generating estimates for nighttime anglers, as well as anglers that utilize private access points. And I was wondering if there has been any talk of doing some sort of adjustment to MRIP to try and capture some of those anglers.
Yeah, no, that's a great question. So with that, I can speak to some of the large scale federal surveys that we do a little bit. We use our intercept survey that we use on the Atlantic and Gulf coasts and in Hawaii does have, in the stratification, we do have night strata in the design. So people are going out, the state samplers are going out at night, not all the time because there's less fishing there, because you don't want to be inefficient in your sampling. But so that is part of the design. So we do capture night fishing there. With the private access, it's always a tricky thing that impacts all surveys. Part of what we do, so we couple the intercept survey to estimate catch rates, and we couple that with an off-site effort component, and that effort is meant to get at, private access effort as well as public access effort. There's an assumption there, though, that's made that, the private and public catch is the same, and maybe it's not. We're part of the some of the work we were doing with our state partners is trying to think of ways to study that. I mean, unfortunately, you can't. It's so hard to figure out, private access fishing, and if catch rates or catch composition is really different, private access versus public access. But it's something we're all aware of and trying to think about, new ways we could look into that.
All right. Thank you. Anyone else have any questions? You can go ahead and jump on here. And yeah, so we're right at time here. So thanks everyone for joining. I really appreciate everyone's time, and we'll have another one of these in October. But also for those attending the AFS National Meeting, we're also going to have a Angler Survey Committee business meeting, which will be held on the Tuesday, the 22nd at 2 o'clock in Grand Gallery Overlook D. I sent out that invite to the group earlier, and I'll follow up as we get closer to that. But essentially, we're going to try to outline the paths forward with developing best practices for angler surveys in that meeting. And with that, I'll appreciate everyone joining in, and sure we'll stay in touch and chat very soon.
Thanks, Dave.
Thanks all.